Remember this from the last video? Well, it now supports up to 80 watts and has a desktop app. I've upgraded with the XYS3580 and an ESP32 to hijack the Modbus. So no more touching knobs, we can now do it hands-free with Wi-Fi. I've open sourced the code and attached it in the description. So what we have here is the XYS3580, and we want this module because of this teeny tiny little Modbus connector right here. Using an ESP32, we're able to hijack the signal and allow full Wi-Fi control. Pull the wires out and be very confused about the polarity because of the random colors. I still stand by my choice of purple. So the new module should just pop in place. Alright, after some adjustments, the new module should just pop in place. We can now reattach the banana wires, just ensuring the polarity is correct. We're removing the module's fan so that we can splice in the case fan so that the module can control both of them and only turn the fans on when required. By removing the fan, we also get the benefit that we can up the voltage on the spoofing module to 20 volts. This allows us to draw a lot more power. This is going to be useful as this module can draw up to 80 watts. We can now connect the input wires, once again ensuring polarity is correct so that we don't blow the module up. Plugging in the power, we can see that everything works and we can now move on to the next step. Unfortunately, this perfectly adequate length is not suitable for this situation. So I needed some signal wire, so I stole some Cat5. It's free if you don't value your home network. Now we connect the speed sensor wire through a 4.7 kilo ohm resistor to GPIO pin 2. We can go ahead and secure the ESP in place with some hot glue. Make sure to leave a hole in the side or program the module before you close it up. Remember guys, hot glue is hot, so try not to burn yourself. So we can now plug in the teeny tiny little Modbus connector, and we should be able to close the project up before we move on to the programming side. We can see that the module powers up and everything's working. Using AI, I was able to reverse engineer the Modbus protocol and write this Arduino sketch. All you need to do is put your Wi-Fi details in here and then flash the sketch. If you're using the ESP-C6, just ensure CDC on boot is enabled. This allows the serial function of the desktop application to function. Here you select your serial port and your device from the list of devices. If you don't see this list of devices, you'll need to go to File, Preferences, and insert the string here. I'll put this in the description so that you can just copy and paste. After inserting the string, you'll need to go to the board manager under here and search for ESP. You'll see there are two modules. You don't need the top one, you only need the second one. You can click install, and after the install finishes, the devices will show up in your boards list. Now all that's left is to flash the code. Once the code is installed, you can pop onto your home router and find the IP of the device there. This would be for if you want to use the web interface. Unfortunately, the web interface is a bit limited, and this is why I decided to write my own application. Well, with the help of AI. So once the desktop app is opened, you can select Wi-Fi or serial, or you can scan, where it will use MDNS to detect the device on your network. Once the device is detected, you'll have a lot more options in controlling the system. There's a pre-configured battery charger option as well. As an example, here I'm going to configure a demo for a battery, and this is how you would start a charge. After a warning to make sure you haven't made a mistake in the settings, it'll pre-configure and start the charging. As you can see down here, you've got graphs for voltage, current, power, your VI curve, and the fan's RPM. And here I'm giving a real-world example where I'm setting it to a 1S 4000 mAh battery. Once connected, you can see all the statistics in real time. One awesome feature is that when the charge is complete, the application will notify you. You can also close the application and it will run in the background, and will still notify you once the battery charge is complete. Here I'm disconnecting the battery to show how that would look. As always, thank you guys for watching. Like and subscribe, and I'll see you in the next one.